Hello, welcome back to Cracking the Cryptic. And as I feared a couple of days ago, my throat is beginning to get worse at the moment. I'm sure it'll be temporary, but maybe I'm mad today. I've chosen to have a look at a puzzle by Dorlier which involves galaxies, and this could take a long time. So I could be talking to you a lot, or you might have the rare video of a lot of sounds of silence in it today. We shall see. But I'm really looking forward to giving this a go. Dorlier is a fantastic constructor who has become active in the last year or so, and I think came up with the counting circles idea. That's not in use today, but Dorlier is always very inventive, and we have something, a sort of ambiguity we've never seen before. I'm absolutely fascinated to give this a go. And I'm going to give it a try because I love the puzzles. So that's what's going on. There's a lot of 8s written into the puzzle, which is a painful reminder of yesterday where I failed to notice a knight's move 8 quite early on that was available throughout the puzzle. Mr. Knighty let me down. And lots of you commented on it. So in the spirit of me not noticing things, maybe everybody didn't notice that it had already been commented on, or maybe they just wanted to add their names to the people who'd seen how dumb I was being. I don't know. Anyway, thank you for pointing that out. And I will do better today, but I will still have infelicities and errors because that is the way that we operate when we solve live Sudoku. Especially Sudoku as variant and as hard as we get on this channel every day. But I'm really looking forward to giving this one a go. Let me first of all mention that there are some quite tough puzzles on Patreon in the evening attractions Sudoku hunt, which you can enter until the 20th still. And there is an even harder puzzle available, Simon's Solve of Emery Kalotoglu, which is a brilliant masterpiece, both the solve and the puzzle. Those are on Patreon. There is always some extra content there. My crossword video has gone up as well, so do check that out. What else is going on? We've got all kinds of things. There's Wordle in a Minute every day on the channel, of course. There's all of our apps, which involve various domino Sudoku, amongst other things. There are items in our merchandise that you might be interested to get, and Sven's Sudoku pad, which is always well worth having. Check them all out, but the first link under the video is to Segue Ursa by Dorlier. Segue is, I think, a sort of Spanish word for a progression or a carry-on, a run-on from one thing to the other. Ursa is obviously the Latin for bear and features in Ursa Minor. So I think we're looking up at the skies today because we have galaxies and kropki dots. I learned a very interesting fact recently that I think this is right, and astrophysicists will correct me, that if you look up into the night sky and think, how many galaxies am I seeing up there? The answer is almost always 1. You can't really see any stars outside the Milky Way with the human eye, which is an absolutely fascinating fact to someone like me who gazes up at the stars and wonders about them and doesn't realize things like that. Anyway, let's have a look at the rules of this. Normal Sudoku rules apply. 1 to 9 will go in every row, every column, and every 3x3 box. Now, in Dorlier's universe, no doubt we will see several galaxies. It must be determined whether each white dot is a kropki dot or the center of a galaxy. Now, for kropki dots, the 2 digits joined by a white kropki dot have a difference indicated by the number on the kropki dot. So if this was a kropki dot, this 4, the 2 digits would potentially be 6 and 2. Now, with a galaxy, the situation is different. A galaxy is a group of orthogonally connected cells that has the white dot at its center and is rotationally symmetrical through 180 degrees. You may have seen other galaxy puzzles on the channel, and that will normally be true. However, there's some extra rules this time. The number on the central dot of a galaxy indicates the number of cells, n, in the galaxy. And this galaxy must contain all the digits from 1 to n. So let's say that this was a galaxy dot. This would be a galaxy of size 8, which was rotationally symmetrical. Could it be, yeah, it could look like that, as long as it had the digits 1 to 8 on. But there is more. Galaxies also, galaxies cannot share cells with any other galaxies or cells joined by a kropki dot. Fair enough, that keeps things separate. Galaxies also function similarly to region sum lines. Digits within each 3x3 box sum to the same amount if they are within the same galaxy. So this galaxy I've just drawn won't work because there's no way that the digit there is going to add up to the total of the digits there. This region sum may be different for different galaxies. So these are kind of region sum line, rotationally symmetrical galaxies. They're also Ren bands in a way. They have the digits from 1 to n on. I mean, that's a reasonable amount of restrictions and maybe explains how D'Orléans has only populated this grid with a few 4 and 8 dots, which seems absolutely absurd when you first look at it. Right. Time to gird your loins, zip up your spacesuit, and let's get cracking. Okay, what on earth do we conclude about galaxies? Right, any of the 8s that are kropki dots have to have the numbers 1 and 9 on. So in this column, they can't both be kropki dots. One of those, at least, is a galaxy. Same in this column. Okay, if I'm going to observe that a kropki dot functions a little like a galaxy because it will always be collecting a rotationally symmetrical piece because a 2x1 domino is naturally rotationally symmetrical about the circle. So I'm going to draw some lines in the grid where whether this 4 is a galaxy or a kropki dot, that line is going to separate the digits reacting to the 4, or some of the digits reacting to the 4, with other pieces. Again, you have to draw a line between dot cells. Then I can draw a line up here, because once these are in the galaxy and these, if it's a galaxy, it may be a kropki dot and that line's still appropriate. But if it's a galaxy, once these are in the galaxy and that isn't, then those can't be because of the rotationally symmetrical rule. Now, I was about to say this galaxy is impossible, but it's far from impossible. It could look like that if it's a galaxy. I'm going to carry on for now with my lines between 4s and 8s. And now I can draw one here because of the rotational symmetry issue around this 4. There being a line between those two cells means there must be one between those. I can draw a line between those two 8s. It gets hard around the bottom. I can draw a line there. And that may be it in terms of the lines I can draw straight off. So maybe it is time to consider this. See, I'm thinking, if that had a 1, 9 on, how could you possibly... Oh, no, you don't have to have a 1 on a 4 kropki dot. A 4 galaxy. This is not possibly a 4 galaxy because of the region sum line rule. So, if, given the bar that I've been able to put above that 4, yeah, I can also, have I not done it? Put a bar below it. I haven't. There we go. And now this is either a pair of digits with a difference of 4 there, if it's a kropki dot. If it was a galaxy, it would have to extend like that. That is not possible because it would have the digits 1, 2, 3, 4 in. And that digit would have to add up to the sum of those 3. That can't be happening. So this is a kropki dot. Let's give it a color, yellow. And I think that's going to apply to any 4 who couldn't have 2 dots, 2 cells. As a galaxy, if the 4 could have 2 cells in one box and 2 cells in another, like that one, it could be a galaxy. But this couldn't, because it would look like that. So that is also a kropki dot. I mean, actually, finding 4s that are kropki dots is not wildly helpful, but it's at least progress in the puzzle. This now could not possibly be a galaxy taking in those two cells. Again, you'd have a digit there that would have to add to those 3, which are all different. They're in the same box. So we can bound that and say that that is a kropki 4. This one, not sure. It couldn't look like that, or like that. If it was a galaxy, it would be straight up and down. The reason it couldn't look like that, for instance, is you'd have the same digit on the region sum line rule, here and here. Now, there was a point during my thinking where I was thinking that every 4 that was yellow was going to be a 1-5 pair. That's clearly not true. If it was, it would sort out something about this very quickly. It's clearly not true because those two yellow dominoes can't use the same digits. Now, how could this be a galaxy? Okay, something like that, I hear you say. Right, I have to find an 8 that either can't be a galaxy or has to be. Now, we did decide that at least one of these was a galaxy. How could this be a galaxy? Oh, that's quite interesting. Right, where would the galaxy go? It can't go into row 7 because it can't go into row 9 under rotational symmetry. To get out of this box and fulfill the region sum line rule, it's going to have to exit the box somewhere like here. Now that's fine so far, but where else could it then go? It can't carry on because it'll bump into this 8. It can't go north over here because it'll bump into this 8. If you extend it in box 8, you've got a 6-cell area and 2 1-cell areas that can never equate on a region sum line basis. So I don't think this 8 can be a galaxy. I'm going yellow on this one. And now I've got some digits. Well, I've got a pair. That's a 1-9 pair. Now, this is definitely a galaxy. What is the color for a galaxy? Or, well, let's make the galaxies different colors that aren't yellow, maybe. So I'll go blue on this one. The blue and the dim and the dark cloths of night and the light and the half-light. Okay, knowing that this is a galaxy, well, yes, it does give me something because it's actually similar to this pattern. It's actually very similar to this pattern. So imagine that this galaxy does not go into box 2. I ask you to imagine that. Then it cannot get into row 6 because of the rotational symmetry rule. And then we're left with exactly the same problem as here. You could extend it out of the box. Oh, bother, we're not left with exactly the same problem as there because it could keep extending in that case. So the galaxy could look like that. And then I think you could make the region sum line business work. Well, could you? No, hang on. The numbers are known, aren't they? They are 1 to 8, which add up to 36. I know my triangular numbers by now, up to 9 anyway. Then you would divide those into 3 lots of 12. Yeah, that definitely could work. Oh, but it's certainly worth thinking about this. Any 8 galaxy is going to have a total digit sum of 36, and it's going to have to divide up. So if this was a galaxy, we were postulating that earlier, then it would divide up into 18 there and 18 there. Actually, that seems annoyingly plausible. bother. I thought I was about to prove that it does go into box 2. Actually, maybe it doesn't. Maybe this is the only shape it can have. Right, that's worth thinking about. If it went into box 2, how many boxes can it possibly occupy? I think the answer is only 2 or 3. I don't see how this shape could get into 4 boxes. Yes, I do. I've found a way. But there's no way that that is the galaxy shape, because that one would be equivalent to the sum of those 5. That's not going to happen. So it doesn't go into 4 boxes. I now believe that it doesn't go into box 2, maybe. No, I can't say that, because this eye shape is available as well. Oh, bother. No, it's not, because this cell is not available. So that isn't. We can't come down here and get one there. Oh, I mean, there are more galaxies than I dreamt of in your philosophy, Horatio. I hadn't thought of that, but it seems possible. Oh, bother. Okay, maybe I cannot. Maybe this is not the next place to focus on, which is very surprising. Wow, I'm really stuck here. At some point in this puzzle, I'm going to have to go to numbers as well. That seems a long, long way away. Goodness me, what am I meant to do next? We've got that as a possibility. I don't know. This is the only galaxy I've been able to definitely identify as a galaxy so far. And I'm absolutely stuck to know how it's made up. That's possible, is it? No, those 2 couldn't add up to those 6. Okay, well, maybe there are. Is there any cell that must be used? Seems unlikely. I keep looking at this and wondering if there's a reason that cannot be a 1-9 pair making 8. I certainly can't see one. That and that can't both be galaxies, because they would all contain 1s and 9s. That's too many in column 8. So one of those at least is a galaxy. I don't know, am I meant to think about where 9s go in the puzzle? Or something like that? Because they wouldn't go in galaxies, ever. It's very hard. I mean, yes, if that was a galaxy, the 9 in the box, actually no, it could be in that kropki dot. Ah, bother. Okay. It's very hard for me to know what I'm meant to be doing. Let's think about this again. $36 is its total. Now, on something like that, it could be 12, 12, 12. Oops, that would also be 12, 12, 12. 9, 3 would not be one of the little 2-cell pairs, so they would be 7, 5 and 4, 8, and you'd have 1, 2, 3, 6 in the middle. That doesn't tell me it's not possible. What was it that I was coming up with here? That's tricky, because if you started with that, you want to put a third cell in box 2. And there is nowhere to do that, actually, without repeating a cell in, well, having an extra cell in box 8, which won't work. Going into that cell, or... Yeah, okay, so maybe... Do I actually now know that this doesn't go into box 2 only? So maybe this that I came up with is the only alternative to that. It doesn't seem likely, and it's very hard to prove which is going to be right. It doesn't seem likely to me that those are the only 2 alternatives for this galaxy. Can you see another one? It might be true, though. That's quite interesting. Because let's try and be a bit more rigorous. Sorry. If we went into that cell, then we've definitely got these cells connected up. The extra cell has to go into box 4 to extend its length to 2. That is the only way if we're using that cell, if we're going into box 4. If we're not going into box 4, we're going into box 2. Now, there are different places we could do that. So we could do it there. But we run into these same problems. You can't have 2 against 6. You can't get 3 cells in this box and 5 in this one. There is no way. I've looked at all the possibilities. It doesn't work. So the only alternative is this long S shape with... It's not like that, is it? It's like that. With 3 in box 2, 3 in box 5, and 2 down at the bottom. Now, what do we know about the numbers that would happen here? Because I've worked out the numbers for the horizontal piece, sort of, which would have had a 1, 2, 3, 6 in box 5. Here we're looking at a pair that is either 8, 4 or 5, 7 at the bottom, because we're dividing into strings of 12. No, okay, the interesting thing I found out about this, nearly. Okay, is that would make this 8 kropki dot a 1, 9 pair. It would make it a kropki dot. It would be a 1, 9. Now, where would you 1 in... Where? That's beautiful. Right. Look at this shape. I'll just sketch this in. If that was there, this is now forced to be a kropki dot with a 1, 9 pair on. Where would you put 1 in the blue galaxy? There is no way you'd be allowed to. Isn't that brilliant? So we can rule that out. I don't think there are any other shapes than that. So that is the galaxy I'm drawing in. Again, as always, feel free to ping me in the comments with the other shape that you've come up with. But bear in mind, it has to obey the region sum line rule as well as all the others. So 4, 8 as well as the rotationally symmetrical rule. Those are a 4, 8 and a 5, 7 pair. That is 1, 2, 3, 6. Is this going to give me anything else? This, we worked out, couldn't go that way or that way. The only way it could have been a galaxy was that way. That's become impossible. It's a kropki dot. This, can we work out that this can't be a galaxy? Now, for it to achieve rotational symmetry, the trouble is I'm looking at that and going, that could be a galaxy. But could it? It would have to have the digits 1 to 8 in, and these ones would have to add up to 18. using 4, 5, 7 and 8, which in total add up to 24. You'd take out the 5, that would be 4, 7, 8. This would be 1, 2, 3, 5, 6. Wow, I mean, it would really get a lot done if this is a galaxy, because I think it probably has to look like this. However, I haven't really thought very hard about that cell, for a good reason. That won't work at all. Too many cells in box 4 compared with box 8. So this is either a 1-9 pair or a galaxy, I think, that looks exactly like that, where we know an awful lot of digits suddenly. Wow. I've just thought, if that was a 4, 7, 8 triple, these cells would be 5 and 9. That one can't be 5 because you can't put 1 or 9 here. So that would have to be 9. That would be 5. This would be 1. It would sort out so much stuff, but it seems to work. So it's probably actually right. It's just very frustratingly hard to say what is going on. Oh, how can this be a galaxy? Well, now I think it would have to look like that, which again does work. But then you've got the problem that these 3 cells have to add to 18 from the numbers 1 to 8. Now you couldn't put 4, 7, 8 there because of these cells. You'd have to use a 6 and the other pair that adds to 12 that's not there. So then you'd have a 4, 5, 6, 7, 8 quintuple. These would be 1, 9, and that would be a 2, 3 pair. And that works fine. If this was 6, I mean, the interesting thing about that is 1, 2, and 3 would appear here. What would be in this pair? 4, 8 or 5, 9? Four, 8 would determine the identity of this 12 pair. I sense I'm not thinking about this puzzle in the right way. But I think I have to soldier on with the only way I've got, otherwise I'm just going to get stuck entirely. So let's keep trying to rule out that galaxy. Or should I try and rule out this being a 1-9 pair, which forces a galaxy down here? Again, it looks like it could be that shape. I think there may be other shapes available. Although there probably aren't in this box, because again, if you go into this row, you're not taking very many cells. One of these at least has to be a galaxy, and I'm thinking now that the only ways to make these into galaxies are that shape and that shape. I don't see how you could do this. If you try and pinch a cell in those regions, you're not going to get enough to get the equal sum line going. Because you'd have to go flat. You can't go to that row because symmetrically opposite is outside the grid. Yeah, that is true. You'd have to have 2 like that, and you can't do that there. You could do it there with 2 like that, but then you've got to pick up another cell here. And you've got a 1 cell against a a 5-cell area. Right, so these are, well, one of these, I'm just going to sketch in the shapes so that I can see them. One of them is that shape, maybe both of them. The alternative is that one of them has a 1-9 pair on instead. Now, for this to have that green shape, this is a 4-7-8 set. And we get 9 here and 5 here. Oh, it doesn't work at all. Right, this green one doesn't work at all because the 18 sum has to be 8, 7, 4. You can't put 5 here because you're not allowed to put 1 or 9 there. If you put 9 there, you have to put 5 both here and here, and that's a clash. So green is wrong. Red must be right. Red is a genuine galaxy. And the place where I was trying to put the green galaxy has a little yellow kropki dot with a 1-9 pair on it. Okay, so even though it had worked out how the numbers would work in the middle, they didn't work. Good. Okay, now, this set adds up to 18, but all we know, well, we don't know anything about it except it's obviously made up of the digits 1 to 8. So that could be 873, 864, or 765, and I really don't have a clue. This can't come from 159, so it's either 2637 or 48. Now, come on, what have we learnt by finding this galaxy? Very little, it seems. So maddening. Can we postulate more about this, which is the only way this galaxy could be a galaxy? Can we say that can't be a 1-9 pair? I don't think I've got any wherewithal. Okay. 9 has to be outside the galaxy in this box. Actually, also in that one, I don't know, but it has to be outside it in this one. If 9 was in one of those cells, then we fix 1 and 9 here. Oh, goodness, I don't know. Can that be a 1-9 pair? I don't see the problem. I don't see why it can't. How on earth are we ever going to get the data here? Okay, can this be a galaxy? Well, that eye shape is available. That is possible. Although, again, here you'd have to have 6 and a pair that added to 12. That's interesting. That is not possible as a galaxy. And I'll tell you why now. Those can't be in this galaxy because their matching would be outside the right. This would have to be the shape. You'd have to get 3 cells into this box. Now, I think I know that this is not possible, and therefore this 8 is not a galaxy. How do you know, Mark? Here's how I know, guys. These digits have to add up to 18 on the region sum line rule. They couldn't be 8, 7, 3, because you need one of those digits in there. They couldn't be whatever the other one is, 8, 6. They could be 864 or 765. But then you will have used 4, 5, 6, 7, 8 up here. Now, how are you going to make this up using the digits 1, 2, 3, 9? This kropki 4, it's impossible. So that I is impossible, and this is a 2-cell kropki dot, which no doubt won't help me at all. Well, it does. It does. I see how it does. That is a 1-9 pair. Forget that 1-9 pair. That's not interesting. What's interesting is that this is now not a 1-9 pair because that digit can't be 1 or 9. So now we are looking at a galaxy here, and it has to look like that. And we can colour it in. Somebody was getting very exercised that I wasn't colouring in shapes around the edge of the grid last time. That's a peculiar form of OCD, but if it helps you, I'll do it. There you go. Right, so this is a galaxy using the digits 1 to 8. Where is the 9 in this box? I don't know why I'm starting with that. It's in one of those cells. And that was a stupid place to start. It could be there if that was a 5. Right, these add up to 18. Now I'm getting to know the combos. They are 864, 873, and 765. These add up to 18. What do these add up to? Either 14, 12, some even number that maxes at 14. Ooh, if they add up to 18 and that was 14, that's 32. These have to be at least a 13 pair. And the digits that are in this adding up to 18 have to be in these 4 cells. If it was 876, they couldn't both be here. This is always an odd pair, so 7 would be up there. Right, if this was 876, this would be, it can't be 876, that's the wrong total. It could be 765. This would be 1, 2, 3, 4, 8. I've got 5, 9 to go in there and a 7, 6 pair. That's possible. Let's try it with 8, 7, 3 here. This is 1, 2, 4, 5, 6. That's 7, 3, and that's 9, 8. I wanted to not even find 2 possibilities. There may even be a third. If that is 8, 6, 4, this is 1, 2, 3, 5, 7. That's 4, 8, and that's 9, 6. Oh, there are lots of possibilities. Every possible set of digits that adds up to 18 there gives one possibility. Bother. Do they rule out possibilities here? That's very unlikely. 8, 6, 4 makes those 2 odd. 7, 6, 5 makes those 8, 4, interestingly. But it's still possible. And 8, 7, 3 gives 9, 5, 5, 1, or 2, 6. Far too many possibilities. Right. That's annoying. 1 and 2 must be in this group. So uninteresting. Okay, let's go back to the 1, 9 pairs that I was forming here. Or maybe, can we colour these? Not really. 9 is either there, in which case that's 9 and that's 9, or it's in one of those 2, in which case that's 9 and that's 9. Oh, 1 has to be in this 5-cell section. It's not in the 3-cell section that adds up to 18. So it's in one of those cells because of that 1, 9 pair, and that's forming a virtual X-wing with 1, 9 there. This cell becomes a 9. There's our first digit after just 32 minutes. We get a 1 there. That's a 1. That's a 9. Now 9 is in one of these 2 in box 7. That's not a 1. I mean, that's been available for ages. I don't think that's going to actually do anything. But still, nice to put an actual digit in this rock-hard grid. I'm realizing I really shouldn't have taken on this puzzle now. Now, those aren't 1s. That's a 1. So the 1 in column 1 is up there somewhere. Those aren't 1s, are they? So the 1 in box 2 is somewhere here, and that's not a 1, and we get 1 in the central box there. That fixes 9 and 1. 1 is in one of those two positions. If it was there, that would be a 5, which would sort out this pair very nicely. It's these sets that make up 18. Maybe they have to be the same group of digits. If they were different, what happens then? I don't think enough does. This can't be a 4-8 pair, I've just realised, because that would kill this cell. Not very interesting. If that was a 1, that would be a 1. If this is a galaxy, it looks like that, and that's a 1. And that's 2, then that's 4, and that's a 2-3 pair. Let's think about that for a second. This would become a 1-9 galaxy. It hasn't just become a 1-9 galaxy, has it? No. But the thing I haven't thought about for a little while is what these 3 are. These 3 add up to, if this is a galaxy looking like this is sort of number 2, those add up to 18 on the region sum line rule. Those add up to 12, and those add up to 10. These would add up to 5. They would definitely be a 2-3 pair. What would that do? Would that do anything to the puzzle? There'd also be a 2-3 pair in the galaxy up here, and a 2-3 there. And therefore 2 and 3 would have to be in these cells. I rather think they'd be in the galaxy down here, because they probably have to be, although actually I haven't ruled out 3, 8, 7 from there. Oh, goodness. It's very hard to rule anything out from being a kropki dot. There just aren't enough digits in the puzzle yet to do anything like that. So that's dreamland. 9 in the central box goes in one of those cells. 9 is there. 9 in box 6 is in one of those two. I hadn't rationalised that before. And if it's there, then that's a 9. So the 9 in row 4 is in one of those two cells. In fact, 9 in this column is not in those. It's in one of those two. Either that is a 9 and that's a 9, which frees these up, or they're both 9s and they're both going with 5s in their kropki dots. So both these cells would be a 5. One of those two would be a 5. One of those two. Does anything go wrong with this potential arrangement of 5s? We need a 5 in the red region. We need a 5 in the green region, which is going to have to be in one of those cells now. It's quite punchy on 5s, but it hasn't broken as far as I can see. Oh, that's maddening. I just need one breakthrough and we're cruising a bit in our spaceship. One of these is a 1. How can I use that? I mean, yeah, for that not to be a 5, that has to be 1 and that has to be 9. For that to be 5, 7, you get 1 there and 9 there. This would then have to be a 2-6 pair, which would give a 2-6 X-wing, which would put 2-6 there, which in turn, weirdly, would make that a 1-9 pair. It's far too complicated to be part of a Dorlier puzzle. I mean, it's very pretty chain of circumstance, but it's not what we're looking for. Okay, maybe I should think about where these three cells appear in this box, because those three, which add up to 18, and 9 appear here. I think what I'm saying is that these four add up to 17. That's probably not a huge insight. It's very difficult for this cell not to be 5. Right, we worked out what was going on if 5 was in one of those. We ended up with 5 in one of those, and it was quite interesting. Actually, let's do it again, because if that's not 5, then 1 and 9 are in those positions. No, I started with if this is a 5-7 pair, so I'm going to do that again. If this is a 5-7 pair, what I've started wondering is where does 5 go in box 4? Let's see what happens. So if that's a 5-7 pair, then 1 and 9 are outside the box, and I think the 4 kropki has to be a 2-6 pair. Now, how did I make all the conclusions I made before on 5? If that's a 5-7 pair, I don't even know how I did it now. That's really annoying. Oh, this was a 6-2 pair. Then we had a 6-2 here. Ah, that is quite interesting. Then 5 has to end up here. If that's not a 5-7 pair, 5 is in one of those cells. So 5 is always in one of these three. Now, that is not a 5, because this can't be 1 or 9. So 5 is now always in one of these three. So if 5's not there, it's in one of those two. If that's 5-7, we've got these 5s. Maybe that's what I should be thinking about. 4, 5, 7, 8 all see these cells, as do 9 and 1. So that's now a 2, 3, 6 triple. That's weird, isn't it? So these two are the same as these two. They're either a 4, 8 or a 5, 7 pair. And this is now either a 4, 8 pair, 7, 3 or 1, 9. That is annoying that all of those remain possible. The 1 or 9 would go with a 5 here. That 2, 3, 6 triple was surprising to me. So that pair is the same as that pair and has to go in those cells. Now, can these be part of a galaxy looking like that, which needs 18 here? No, because that galaxy would not be allowed a 9 in it. So this is not a 2-shaped galaxy. This is a pair. Wow, I mean, that is a complicated deduction for me. But this is now a 1-9 pair. We know the order. That's not a 1. That's not a 1. 9 is here in the corner. How are we doing on 9s? That's a 9. That's not a 9, so that's a 9. That must be 1. That's not 1. Come on, 9s. Show yourselves. Oh, we've still got that little X-wing of 9s. Ooh, and we've got that 1. Now, if this was a kropki, that would be a 5. Didn't we know the order if it was going to be a galaxy? Yes, because the bits have to add up to 5 on either side. So that would be 1, 4, and this would be a 2, 3 pair. So that digit ends up being 2, 3, or 5. This pair, don't know. We got the 9 down here. These 3 are the same as those 3. So that digit's the same as that. interesting finding, but it doesn't really butter any parsnips. Can this not be 4, 1 and a 2, 3 pair for some reason? If that was 2, 3, what goes in here? Has to be 4, 8. That would have to be 5, 7. So you'd have 4, 8 there, 4, 8 here. Oh. 9's in one of those cells. Right, now, I'd forgotten to think about this thing. So, if that is 8, 7, 3, this is 1, 2, 4, 5, 6. That's a 3, 7 pair, and that's an 8. I'm putting those in as possibilities. If that's 8, 6, 4, this is 1, 2, 3, 5, 7. That's a 4, 8 pair, and that's a 6. And the alternative is 7, 6, 5 here. This is then 1, 2, 3, 4, 8. You've got, that doesn't work anymore because you've only got 5, 6, 7. So this is not an 8, 6, 4 pair. It's either 7, 6, 5 or 8, 7, 3, and it always has a 7 in it. Can I use that? It seems very unlikely. Yes, I can, because it always has a 7 in it. So there's never a 7 in this part of the... So unless I've done something wrong, there has to be a 7 in this. So how did I think that could be a 4, 8? The first one I analysed was 8, 7, 3. I said this was 1, 2, 4, 5, 6. 9 there, 3, 7 here, 8 here. That's fine. If this is 7, 6, 5, this is 1, 2, 3, 4, 8. And it doesn't work. So I've got it wrong, haven't I? 7, 6, 5 was impossible. Sorry. That wasn't what I analysed. 7, 6, 5 was impossible. 8, 7, 3 or 8, 6, 4 are the two possibles. So one of those is 8, and 8 either goes there or there. Bother, bother, bother. Now, I don't suppose there's any chance of that helping. Well, it puts 8 in one of those cells, along with 5. I don't think that helps. Oh, I've only just noticed that 4, 5, 7, 8 combo also sees all of these cells. This is just irregular Sudoku, and I'm forgetting it. So this can't be a 4, 8 pair now in this kropki domino. It's either 3, 7 or 5 under 1 or 9. Also, 4, 5, 7, 8 can't be in these cells, which feels less helpful. Although that one can't be 1 or 9, that one can't be 9. I'm certainly prepared to pencil mark at this stage. Oh look, I've got a 1, 2, 3, 6 quad. If my pencil marking is right, and it is, 4, 8, 5, 7 form a quad in those two and these two cells. That's taken a long time to figure out. Now, I've got a 1, 2, 3, 6, I've got a 2, 3, 6 triple. That's a 1, that's a 9, that might get me going. We get a 5 there. This is now a 4, 8 pair. That's a 5, 7 pair. I've got a lot of extraneous corner marks there. 2, 3, 6, 1. 5 and 8 are in this group. That can't be 8 because we just put 8 in a set up there. So that's 4, that's 8. Now these can't have 4, so they're not 8, 4, 6. They're 8, 7, 3. This is 1, 2, 4, 5, 6. Which adds up to the right number, 18. So there's no 5 that side. That's not a 1. That's not a 1, in fact. But 1, 2, 4, 5, 6 means that's an 8. This is a 3, 7 pair. That becomes an 8. 3, 7, 8, 1, 9. That's not a 1. That's not a 1. There's only one place for 1 here now. Is that because it's the last one in the grid? Yes, it is. How are we doing on 9s? We need to put the last one in here. And that must go with a 5 in its kropki dot, leaving a 2-6 pair down here. Now, these are from 3, 4, 7, 8, and they have to add up to exactly 18. So they're 8, 7, 3. That's a 4. 8, 7, 3 go in these cells because they can't go in red again. That one's not allowed to be an 8, therefore, and that is the same as that. 9. So these are from 2, 4, 5, 6. And it's beginning to come together in a way. Now, what's this pair? That might be 2, 6, 4, 5, 7, 3, 8. No, I don't think I can do that yet. But I do need an 8 in one of those two cells by sudoku. Sudoku is your friend, Mark. 1, 9, 5, 4, 8. These are from 2, 3, 6, 7. 4, 9. This is a 5, 7, 8 triple now. 4 is in one of those two. 5's in one of those three, so one of these two is a 5 in the bottom row. And one of those two is a 5 up nearer the top. These are a 2, 4, 5, 6 triple. So that seems to be a 2, 3, 4, 5, 6 quintuple. And these are therefore a 7, 8 pair. Which, well, yes, there's got to be a 7 in one of those cells apparently, so that's an 8. That's a 7. That's a 3. Yes, that's an 8. This is a 5, 7 pair. And again, there's a 7 in one of those, so we know which way around that goes. 1, 5, 8, 9. Oh, I don't know. Come on, come on. 2, 4, 5, 6 quad there. So that's 2 or 6. And these are a 7, 8 pair. That's become a 3 by sudoku now. These are from 2, 4, 6. I've got a triple in the final column of 2, 4, 6. And therefore the other cells are from 3, 7, 8. But that one sees a 7, 8 pair in its box. And that's 3 in the corner. Is there a corner of a universe? That's 3 in the spotlight. Losing its religion. 3, 7, 8, 1, 9. These are from 2, 4, 5, 6. That's not interesting. I haven't finished off this galaxy or kropki dot. I think I've done all the others. That's interesting. These are from 2, 5, 6. So that's in the row. I'm going to have to finish this off. Is that a 5 or is that not possible? That would make that a 7, that an 8. We'd have 2, 3, 4, 6 left. That would be a 2, 6 pair. And it doesn't work. Okay, the point is, well, I'm just going to use that this can't be a 5. Because that's a 7 then, that's an 8. The only way to make this up at that point would be a 2, 6 pair which breaks this. I think the simpler way to see that is if this is a 5, that's a 3, 7 pair because we have to get 3 into the column and together they break that cell. So that's not a 5 and therefore this is not a kropki dot. Therefore what it is a galaxy. My goodness, and we know all about the galaxy. It has to add up to 5. It has to use 1, 2, 3, 4, add up to 5 on each side. So we get quite a bit of information. That can't be a 5. That can't be a 3. Now, this can't be 2, 6 or 3, 7 or 1, 5 or 9, 5. I think it's got to be 4, 8 after I've said all that. So there we go. I'm going with that. This is not a 4. More importantly, that's not an 8. It's a 7. That fixes this as a 5. This can't be a 5. We've got a 2, 6 pair here. So we get a 4, 5 pair there. We've got 5, 6 and 7 to put into box 1. That one can't be a 7 in its column. One of these has to be a 4 in the row. So those two aren't 4s. That's a 2, 6 pair. This is a 4. That is a 5 in its row. There's definitely a 4 here. I mean, I do sense I ought to be just finishing off quickly, but I'm going to finish off slowly, because if I made a mistake at this point, I'd quite frankly have to... I believe that in space no one can hear you scream, but I think you would hear me scream. That 7 fixes 3, 7. That can't be a 3. We've got a 2, 6 pair there, so that's a 5. 1, 5, 8, 9, 7. 9, 8, 3, 9. I keep probably looking away from the right sections. That 2, 6 pair has made that a 4, 5 pair. In fact, it made row 2, column 8 a naked 5. Got all but 2 4s in the grid. I'm a bit surprised this is still going to disambiguate, but if it doesn't, again, that scream is back on the table. That's not a 3. That's 2, 4, or 6. Might as well pencil mark this one up. I think 2, 3, 4, or 6. It's a triple we have to achieve. Oh, one of those two is a 3. Yes. It's that 2, 6 pair looking at the top there. Right, that's going to do stuff, because that 3 is looking at that. This 2 is looking into the corner. I think we could be looking at finishing the top 3 rows entirely there. We are. That's a 2. They're not. That's also not a 2. That's become a 4 now. That's not a 4, therefore that's 4. This is 3. That's going to fix 6, 3, 6, 2, 3, 6, 2, 6, 2, 6, and 2. What a brilliant... Oh, I don't get the tick because I've got 2 more cells to fill in. Do I get the tick now? Yes. Wow, that's magic. Segway Ursa by Dorlier. What a fantastic puzzle. What a joy to get to solve that. And literally very little of that worked out as I was thinking. And I'm probably quite poor at visualizing these galaxy shapes. That's maybe part of the problem there, but I don't think there were easy steps that I was completely blanking on. If there were, I know you'll let me know. Thanks for watching as always. Hope to see you again soon, and bye for now.